Yes, ma'am. Your screen is visible.
Okay, my screen is visible. Okay. Now I will explain you about the feature selection technique in your algorithms. How in the models that you build, how do you select the features? Okay.
Ma'am, one question I have,
Hmm.
we will every time we will use that hypothesis testing in the machine learning building, like when you want to do
No,
that feature
why
selection.
every time you will use hypothesis testing?
Like there is
Hypothesis testing.
in only when there is a purpose of like we have to test the statement, then only we have to use, or otherwise we don't use that feature
Yes,
selection in the.
correct. When you have to test some hypothesis, you have to test some claim, then only you will be using. Why you will be using hypothesis testing for all your machine learning models? Not at all required, right? Okay, one thing let me clear you. Always remember the same concept will not be applicable for all the models. The same concepts or the same theories you will not be used. It depends on the use case, what is asked to you. Hypothesis you will be using when you have been given a claim and you are asked to test that claim. So that is the practical implementation of hypothesis testing. In your data sets, it is not that you will not use hypothesis testing, but it is also true that you will not use hypothesis testing every time. Correct?
Yes, ma'am.
Okay.
Yes,
So
ma'am. Main purpose I know that we will only use that without changing all the machine learning model. We have to perform hypothesis testing. It is true or not before changing the model machine learning algorithm. When the statement is like Sarah has told one example, like um, warm conditions are good for not occurring corona COVID. There is a statement has a, is more related to that COVID times, like warm
yes,
conditions spread corona. uh, while corona while you are performing machine learning model on that finding the corona test or corona COVID positive or not, we will test the statement in the particular time without recreating all the model. We will only test that is working or not, affecting or not. Using the data we have to see. That is sir has told us.
yes. Your sir has told correct. No doubt about it.
Ma'am,
Okay.
what is your name? I did not ask now.
Pardon?
Your name, ma'am.
Huh? I didn't get.
Name, ma'am, your name.
Mohini.
Okay.
Okay. Okay. So now I will explain you when you are working on any data set, how do you select the features? What are the feature selection techniques? There are multiple ways to select features, and why do you select features? First, you have to understand that. Can you tell me the reason why do we select features?
For getting the good accuracy.
For getting the good accuracy. For that, feature selection is required.
And for understanding the data. And like ma'am, I
Okay,
know that
okay. I
it is
go with
for.
your point. I go with your point. See, give me complete information. You are telling feature selection is required for getting good accuracy. So you
Yes, ma'am.
mean
Yes,
you
yes.
mean that if I have 100 features and if I select some of the features, then I will get better accuracy, but I was getting with 100 features. Suppose with 100 features, my accuracy value was coming as 90%. And if I do feature selection, my accuracy value is coming as 98%. Your conception is this. Clear?
Like that, ma'am. Like uh, feature selection, I am telling that the most important related features to the particular independent or dependent variables, that is necessary to do that, because only features which are highly correlated with that or highly impacting that target variable, that should be selected, I am telling.
Okay. So you are telling but not giving me complete information. Okay. First, I will tell you feature selection is required. Number one, importance of feature selection. First is feature selection is needed when we have a number of highly correlated features and we have to drop one of the highly correlated features so that our model can analyze it better and can give us robust performance. Robust performance. Okay, that is one case where it is used. The second thing, if I have 100 features in my data set, is it practically possible for me to build a model with 100 features? Definitely not. The complexity will be too high if I have to build a model with 100 features. Do you agree to this or not?
Yes, ma'am.
Wait, let me just add it to the documents. One second, let me just see whether my recordings are available or not. Okay. So, Aditya, where are we? Yes. So, if I have 100 features in my model, in my data set, Aditya, so it is practically not possible for me to build a model with 100 features, right or wrong?
Yes, ma'am. Right.
In that case, what I will do, I will select, say, 15 or 20 features out of my 100 features from the data set, and those 15 features should be the most significant features, which will give me better explainability and better interpretability in predicting the target. And with those features, I will be building my model. So here I have selected my features. From 100 features, I have selected 15 significant features, and with those significant features, I have built the model. Now, there are multiple ways to do feature selection, in machine learning models. The first way how we can do is we take SNS.heatmap,
Yes.
and
Correlation.
from there we check the values for the correlations. Check the correlation values. Now here what we are checking, in that SNS.heatmap is giving us what? It is a matrix, correlation matrix, you can say. Correct?
Yes,
It is
ma'am.
a
Matrix.
matrix, right?
Yes. Yes, ma'am.
Some
Correlation matrix.
tabular data, something like that, it will come. So it is a matrix which will give us the correlation values. From that, we will see wherever the correlation values between an independent variable and a dependent variable. Suppose this is my independent variable and this is my dependent variable. This part, whatever I get, the value in this part, at the intersection of a dependent and an independent variable, wherever the value is greater than 0.75, I will consider that, sorry, one thing, it is independent and independent. Wherever the correlation values between two independent features is greater than 0.75, I will drop one independent feature from my data set. Clear or not?
Yes, ma'am. Yes, ma'am.
Wherever the
I have done
independent features.
capstone project.
Pardon?
I have done that in capstone project.
Okay, yes. Wherever the two independent features intersect to give a correlation value which is greater than 0.75, I will drop one of the independent features. But if in the correlation matrix, I found that the one independent feature is having a correlation value greater than 0.75 with the target, this is an important interview question. In that case, what I should do? Answer me this question. Suppose an independent
It's very important. It is.
Yes. Did you understand the question, Aditya, first of all?
Yes, ma'am. It is a more important feature and more impacting on that particular target. This should be very important in that feature. We have to put that feature in that particular.
Yes. Again, share. Yes. So if the independent feature is having correlation value greater than 0.75 with the target. In that case, what I should do?
We have to put that call a row feature. It should be, this feature should be there in that particular data set.
Yes, this feature should be there in the data set. We should not remove this feature. Why? Because this is a significant feature in predicting the target. So we have to check this value greater than 0.75 wherever it is there between two independent variables, not between the independent and the dependent variable. Correct?
Ma'am, one thing, ma'am, this is the one type of p-value, like, ma'am, this is
not p-value. P-value is what? P-value is the probability
yes,
value which we compare with alpha. Alpha is the significance level. You are
yes,
confusing every concepts. Every concepts you are confusing together.
No, I'm not confusing, but I'm like telling that. I know, ma'am, this is the correlation value. I know.
Correlation value has got, I am talking with you about the correlation matrix, and you are bringing p-value into the picture. See, these things only I don't understand why you people mix all the concepts together. Be pretty simple in your understanding the concept. Now, what we are focusing on? We are focusing on how we are doing feature selection. What are the techniques of feature selection that can be implemented in our machine learning model? The first way is heat map.
Yes, ma'am. First way is correlation. Heat map. Yes, ma'am.
Yes. In the heat map, we check for the correlation values. Wherever the correlation value is greater than 0.75 between two independent features, we drop one independent feature. And if the value is greater than 0.75 between an independent feature and the target, that time we do not drop the independent feature because that is a significant feature in predicting the target. Clear explanation?
Yes,
your explanation should be in the way in which I am presenting. Okay?
Yes, ma'am.
Number two.
Clear.
The second point is variance inflation factor. Now, in variance inflation factor, it is calculated by VIF, which is 1 by 1 plus R square. 1 plus or 1 minus R square, something like that. With this formula, we are calculating the VIF internally. Okay. So, for the VIFs, you check for the values. You check for the VIF values wherever it is greater than 5. Okay. For each of the numerical independent features, if the VIF value is greater than 5, that means those features are not significant and you can drop. Wherever the VIF is greater than 5, you have to drop one independent feature. And then again, you have to calculate the VIF for the remaining features unless and until all the VIF values are less than 5.
We will use for loop and we will rotate that.
Correct?
Yes, ma'am. Understand.
VIF. So based on VIF also, you can do feature selection. Okay?
Okay, ma'am. Understand.
Okay. The third point. See, your stakeholder, suppose he has said that I want this feature 1, feature 2, feature 3, and feature 5 in predicting my target. I want to analyze the significance of these 5 features in predicting the target out of the 20 features that is given to you. So here also, this is an instance of feature selection where it is a customized feature selection. In this, I have been given the specification from my stakeholders to go with these 4 features. So is this not an example of feature selection? Aditya? Aditya, am I audible to you? Sometimes I'm not able to hear you.
Yes, ma'am. You are audible, but I am not able to clear in this point. Stakeholders, features selection. Like,
suppose I mean to say the stakeholder has given me a data set with 20 features, and he said, I want you to build a model with these 4 features. Okay? This is the problem statement that is given to me by my stakeholders. So when he has given me 20 features and asked me to build a model with 4 features, So can I do this or not? I have to do
Yes, ma'am.
this, right?
We
Yeah.
have to do this.
Yes, we have to do it because see, it is fine at the end of the day, whatever our stakeholders say, we have to go by that approach. There you cannot
Yes,
argue and say, no, boss, you gave me 20 features. I will build my model with 20 features. After that, if you want to remove the other features, you can remove. Can we answer like that?
no, ma'am. So how can I answer
Yes,
that?
we cannot answer like that, correct? So when he has
Yes, ma'am.
asked that you build a feature with build a model with 4 features, that time I have to build a model with 4 features. So this is also an example of feature selection technique or not?
Yes, ma'am.
Yes,
It's a
in
very
this,
good technique. I think.
yes. So this is also a feature selection technique in which this is an example of customized feature selection technique in which the problem statement or the ask has been given by the stakeholders and I will do according. So see how many ways we can do the feature selection. The other ways of doing it is not directly feature selection, feature extraction we can do, or you can say feature reduction, wherein you will be using your PCA. Have you heard about PCA, Principal Component Analysis?
Yes, ma'am. I have done this also.
Okay, in this what we do, suppose we have a set of 100 features, we will use PCA to bring it down to a set of 20 or 25 features in which we will be reducing the features from 100 to 25 so that our model is having the complexity of the model is getting reduced, and also like with this 25
Dimensionality
features,
reduction.
pardon,
Like, it
what
is
you
for
said?
dimensionality reduction.
Dimensionality reduction. Yes. Now, if I ask you dimensionality reduction, why we are doing? We are doing this primarily to reduce the complexity of the model, correct? Because
Yes, ma'am.
here I am projecting my data into a set of 100 orthogonal axes, and here 100 axis, and here I am projecting the same data into a smaller space, or you can say into a set of 25 uncorrelated axes or orthogonal axes in which the projection of the data becomes confined to a limited space. Correct?
Yes, ma'am. That's right.
Here, so here my data is projected into a limited space as compared to when I was using a set of 100 axes. So this is an important technique which we will be using it in many of the algorithms. But this technique has a drawback by its own, is it is black box in nature. Here, if I say after you have
We don't know
applied,
about this one.
huh?
And no insights about this particular
Yes, you cannot
PCA.
say which are the like after you have done applied PCA, you cannot say what are the features that you have taken it to build the model, because this is a completely black box nature, and you cannot say, you cannot give the explainability. But definitely your complexity of the model will be reduced, because with 100 features you cannot build a model, so you will be applying PCA to bring it down to say 25 or 30 features, whatever you want, and with those features you will be building your model. Correct?
Yes, ma'am. And yes, ma'am. Right.
Yes. So these are all about your feature
Yeah.
selection techniques. Now,
Last one is RFA, random feature analysis.
hmm?
RFA.
RFE, random
In
feature
feature.
extraction.
Yes, ma'am. RFA or something.
Same, the concept is same. Here you are doing again feature extraction out of a set of the features, total number of features that you have been given. Here you are implementing the same concept.
Ma'am, like, but here there in that particular RFE, there is her has told like there is he's sending the X-train and Y-train to the particular model, and he extracting some of the things.
X-train and Y-train you will have to use to fit the model. Whatever technique you use, X-train and Y-train has to be used to fit the model. And after that, when you are passing RFE, it will be what it will tell you, it will give you the most important features. Now,
Yes,
when
ma'am.
it gives you the most important features, how it will give when you are using RFP, the basic concept is the same. It will be doing some ranking. Did you talk about the ranking?
Yes, ma'am. Yes, ma'am. Ranking.
Yes. So suppose after you train, always remember first the training part of the model has to be done. The fitting part of the model has to be done with your X-train, Y-train, and then you are using RFP to give the most important features. And RFP will make use of the concept called ranking, wherein it will be giving the features rank as 1, 2, 3, 4, 5, 6, 7, something like that. Based on
How
that,
many column?
you will give a threshold value. Based on the threshold, suppose I've given the threshold that if it is greater than 6 or 7, something like that, I will be taking those features. So based on the threshold, I will be selecting the most important features and I will be using those features to build my model. Clear or not? The concept is basically the same. All will be giving you the reduced number of features with which you can build your model. And what is the purpose of reducing the number of features? To eliminate the complexity from the model.
Computational expenses.
Yes, computational efficiency also will be better. So I think so you are 100% clear with the concept, Aditya.
Yes, ma'am. Is enough for this feature selection.
Enough. These are the enough. These things are the enough. And now one thing you explain me, feature selection comes under which part of your machine means when you are doing the machine learning coding, it will come under which part?
It's come under EDA.
Huh?
EDA.
It comes under pre-processing. In
In
EDA,
EDA
what
also we will
comes?
do that.
In EDA, feature selection comes. EDA is what?
Exploratory data analysis, like we have to understand data
Yes,
using
here you
by
will be doing
bots
in
and
EDA, what you will be doing? You will be doing a descriptive statistics of your data to know or to get a clarity on the data. And you will be analyzing some visuals, some univariate analysis, bivariate analysis, and multivariate analysis. In EDA, your focus is only on the understanding of the data part, wherein you will be doing a descriptive statistics, you will be doing your univariate, bivariate, and multivariate analysis. In the pre-processing, what you will do, you will be checking for your missing values. These are also frequently asked interview questions. What are the steps that we follow under pre-processing? What are the pre-processing techniques that we use in our ML models? First is
finding null values.
finding
Null values, and using univariant, we can solve that like mean median mode univariant. And next
first
one
you
is like outlier.
wait. Don't say. First you say that what are the pre-processing, in the pre-processing, what are the steps you will first identify? First is handling null, checking for null values. Then is checking for outliers, checking for duplicate values.
And
Now,
data
if duplicate
transformation.
values are there, you should remove. If null values are there, you should apply imputation techniques. If outliers are there, you should handle it with the treatments.
Capping.
What treatments? Capping or trimming.
Trimming is not necessary.
Okay, fine. Then trimming is not there for you people, then only do capping. If null value you found, you have to apply the imputation techniques. If outliers you found, you have to handle it by the capping method. If duplicate values are there, you have to remove the duplicate values. Then what you have to do, you have to apply
You only told that capping.
You have to apply feature scaling. And feature scaling means?
Ma'am, like first of all, before scaling, we have to do encoding.
Before feature scaling also, you can do encoding, yes. Encoding, feature scaling, all this will be covered under your
data preprocessing.
Even feature selection directly not on you, it can come under your pre-processing, even it can come under your model building also. So yeah, feature selection, encoding, and the last step is checking for data imbalance if it is a classification project. This
Yesterday,
part,
ma'am,
Classification
Like
project.
yesterday,
Hmm.
yes, sir, Anil sir has taken our class and he told like we have to do uh, you have to do train and test it before doing the data pre-processing. That is very important while doing any classification project.
Before doing train and test split, what he is telling, before applying pre-processing techniques, you have to do the train and test split.
Like for imbalanced data.
Yes, for imbalanced data, that is true. What here you can check is what I said. In this part, you will be checking whether you have an imbalance in the target variable or not. But you will not do anything to it. You just see, suppose your target variable is y dot value counts. Just see whether there is an imbalance or not.
Normalized equal to true.
No normalize. What normalize? Normalization will come under your feature scaling technique. Normalization,
Okay.
standard scaling, these are your feature scaling techniques. But I am talking about class imbalance. In the
Yes, ma'am. Like
pre-processing,
not I'm telling that one, but y dot value counts and there is a parameter in the argument in that para value count. There is a normalize equal to true. Then you can see the percentage of the imbalanced data.
yes,
Data which
you can see the percentage of the imbalanced data, but okay, percentage, if you see or if you do not see, that is that hardly matters. If you just see the value count, you can come to know whether there is an imbalance or not, because if it is more than 50% of the minimum class, then that means there will be a imbalance. So here at this part, you should not handle the imbalance. The imbalance part will be handled only after your train test split. After
yes,
the
ma'am.
train test split, you just handle or you just apply imbalance treatment only on the training data, not on the test data. Only on the training data. Training data means the training target variable, your Y train. You're always remember this. Your imbalance treatment should be applied only after train test split, and that too, it should be applied only on the target variable of the training data. Clear on this part?
Yes, ma'am. Clear.
Now, why? If they ask you why we have to do this, because if you don't do this, you will land up into the problem of data leakage. If you are applying
Yes, definitely.
imbalance treatment before train test split, that means you are applying the imbalance treatment on the entire data set, which means that you are actually creating a problem of data leakage. So this should be avoided.
Ma'am, like I understand like data leakage that like there is as an example like as he told there is a mean value when you calculate whole data. There should be some mean value, one mean value when we after train and split there should be a one mean value that should be appended to that uh, data which is already y train, x train and y train and y test and y train. We will take that mean value to apply to that y test missing values without uh, data leakage. Sir, ma'am, I don't understand like, okay, what is the
What is
exact
data?
meaning of the data leakage?
What is data leakage means? When you are applying the same thing across all the entire data set, your model is learning it for all the data set. All the data means for all the observations of the data set. Your trained data, test data, everything. So what is happening is when you are giving a new unseen data, it has actually learned for all the observations. So now the result that you will get, it will not be a robust prediction. It will be a biased one because it has already learned it before. And what is the purpose of your NEML model? When you are giving the validation data, your model should be giving you robust prediction for the validation data. Clear on correct or not?
Yes. Okay,
Yeah.
that means ma'am, okay, data is already seen, so
Data is
that will
already
give the
seen.
same
So
value, same
your
outcome
model
it will
has
give.
already learned from the data. So now your model will not give you the robust predictions, correct? Because it has already seen the data. So when you are giving any data for your validation purpose, that data should be unseen, and that so that the model gives you a robust prediction. Correct or not?
Okay.
Understood this part? Why data leakage should be always avoided?
Yes, ma'am.
Yes. So this is how your imbalance treatment works. And when you apply it for your classification models, always make sure after the train test split only apply imbalance treatment, and that too apply it on the target variable of the training data. I hope Aditya, your
Only for classification.
yes, only for classification. For regression,
Okay.
no, not required. For regression, only feature scaling is enough. So I think so, Aditya, your session time is over, and I hope you enjoyed the session.
Yes, ma'am. Yes, ma'am.
Any other doubts, any questions, confusions, any clarifications which you need?
No, ma'am. First of all, I have to go through this and I have to practice, and later I have doubts.
Yeah, later on, if you get doubts, you can again book a session. So I'll wind up the session, and I hope you enjoyed, and we'll have a nice time again when you book another session. Till then, keep practicing and keep on focusing on your projects and the
Ma'am,
concepts.
ma'am, I want to one help from you. Like, if you have any interview questions related to any PDFs or any,
I don't have
you have.
PDFs. I have all the interview questions stored in my brain. So how many interview questions you want? So if you want interview questions, I will give you n number of interview questions, whatever you ask. One day I will have a session only. I will ask you questions. You will give me answers. All interview related questions.
Okay, okay, thank you.
Okay. Yeah. So till
Okay.
then, you keep on practicing. Have a nice time, and I will connect with you again in future.